All right off the bat, let's find side x. Now, you don't have to use sine, cosine, tangent. Anybody know why on this one in particular? You can use your 30, 60, 90 rules. That'd be fine. Okay? But if it's not 30 or 60, we're going to have to use sine, cosine, tangent. So let's use it right now. Somebody real quick, identify what side x and 24 are. Opposite, adjacent, hypotenuse. Let's start this off right. 24. Let's go, Mahmood. What's the x? Thank you. 24. Hypotenuse. Way to go. And to finish this off, what do I use with A and H? Cosine. Good. Cosine 24 equals adjacent over hypotenuse. This is why your calculator needs to be in degree mode, because you're about to plug in 24 degrees. And then how do we solve them? Put it over 1. Let's cross them up. All right, 30, 24, whatever. All right, relax, smart kids. Look at me, I'm in honors. Look at me, I'm trying to teach honors, right? That is embarrassing, thank you. I am embarrassed. All right, hopefully you can type into your calculator so I don't need to ask anybody, but we should have ended up with, I'll get there eventually, 21 degrees. 21. I also want to remind you too that yes, we could have done 30, 60, 90. We could have done sine, cosine, tangent. We could have also done, this is also available to you no matter what type of triangle it is. Anybody remember this one? Anybody remember this one? Law of sines. That's also available to you. Okay, and that can be done in any type of triangle. All right, so we found a side. How do you find an angle now using sine, cosine, tangent? How do I find an angle? Same process, but something different on the calculator. So find angle A. What are the 9 and the 14? What type of sides are 9 and 14? 7. The 9 is the, and the 14. All right, so we're still using cosine. Cosine A, 9 over 14. What do you guys have to remember when you find an angle? We're not cross multiplying like we did above. I need to go where now in the calculator? I need to use inverse cosine, right? Cosine to the -1 and put in 9 over 14. That is when you find a degree measure. I need to do inverse cosine or sine tangent or, yeah. $50. We're all good, 50? Anytime you find an angle, inverse, inverse, inverse. Going? If you think you have something to ask, go ahead. All right, let's move. This is something we've discussed already on the Regents exam. Somebody asked it. I think Mahmood asked it. If cosine 72 equals sine x, what's the value of x? What do you guys see? Cosine equal to sine. Only one instance that happens when I know what about the angles? 13? There you go. X equals 90 minus 72. 18 degrees. And check it too. You can't leave for 2 hours. You can stay for 3. Is the cosine of 72 the same as the sine of 18? Ding, ding, ding. All right. All right, do me a favor here because this is incorrect guidance, believe it or not. Incorrect. So don't even look, don't cheat. It's incorrect guidance. It's incorrect. Ready? I have right triangle ABC. C is the right angle. What do you know about angles A and B? What do you know about angles A and B? They're not congruent. Well, they might be, but not totally. What do you know about angles A and B, Mahmood? Well, together, anyway. Together.
Yeah.
Together, they do what? They equal 90. Everyone agrees they equal 90. Together, they equal 90. So what do I know about sine of A and the cosine of B if A and B equal 90? What do I know about those two right now? Sine of A, cosine of B. What do I know about those two? No. Okay, here you go. Ready? Let me do this part. Sine of A, opposite BC over hypotenuse AB. Everyone agrees? Cosine B, adjacent over hypotenuse. Let me ask my question again. What do you know about these two? Griff? They're equal to each other, aren't they? Right? We know A and B add to 90, so the sine and cosine have to be equal. So here, you might think add to 90, but no, we've already said these two are equal to each other because A and B add to 90, so I'm going to take 2x plus 0.1 and set it equal to 4x minus 0.7 because sine of A is equal to the cosine of B in this instance. They don't add up to 90. So 2x equals 0.8. Divide by 2, divide by 2. What do we get for the value of x? Yes, Charlotte.
Why? Like, is this instance different because it's in a right triangle?
Say that again?
Like, do they equal each other because it's a right triangle?
Yeah, well, because A and B add to 90. If I wasn't given that this was a right triangle, I'm not doing this problem. The only way I know that sine of A is equal to the cosine of B is because in this diagram, A and B have to add to 90. And that's the only time they're equal to each other.
So, if it wasn't a right triangle, you would set them equal to 90?
No, I couldn't do the problem. Okay? Go ahead.
I'm just
Avery?
confused because couldn't angle A technically be like 32 degrees?
Then B is whatever 90 minus 32 is. Remember, this is already 90 degrees taken away, right? And there's 180 total. So A and B have to add to 90 to get to that 180. Agreed? Sure, you're right, Avery. 32 here, but whatever 90 minus 32 is, that's angle B too. That's going to be angle B. All right, Eva?
So I get that they're congruent, but why can't you still just like add them together to get 90 and then solve for x?
Okay. A and B. Ready? Angle A and angle B. Watch. Angle A and angle B equal to 90. Not the sine of A. Sine of A is a totally different number, right? If I do on my calculator 43 versus sine of 43, those two are totally different. See where I'm going there? Okay, that's why. Because I had the sine of A and the cosine of B. Now, I get rid of these. Now what am I doing? Adding them to 90, setting them equal to 90. See the difference?
Yeah.
Okay, now when I put the sine with them, totally different value. Okay? Any better, Andrew?
Yeah.
Anybody else? Great questions. I know this is why it's a little tough. That's why I threw it on there for you. Go ahead, Charlotte.
I don't understand why in the last one
Yep.
they equaled 90, but now they don't.
Because look, ready? Good. Ready? What was I solving for? X is an angle, right? I'm not solving for this like the cosine or the sine of the angle. I'm solving for the angle. So the angles add to A and B add to 90. But now I'm doing the sine of A, which is different now. Okay, this, let me see if I, the angles add to 90, but watch. Sine of 80, cosine of 10, they don't add to 90. See what I mean? They're just equal to each other. See where I'm going here? Okay, the angles themselves add to 90, but the sine and cosine of each, they're never going to equal 90, but they'll be equal to each other.
Okay.
See the difference? Everyone, we okay? We sure? A plus B equals 90, but sine of A equals cosine of B. Okay, good questions. We on to sectors now? Yes, sectors. Say sector formula, not on our reference sheet. So either cold hard fact sheet or if you filled in the one I just gave you. I have it over here in the guidance one. Measure of the arc over 360 times pi r squared. All right, can you guys help me fill it in? The shaded sector is 12 pi. What's angle AOC? Let's see if you can help me fill it in. 1. Here we go, Meg. Where's the 12 pi going? What's the 12 pi represent? Area. So that's going in for A. 12 pi equals, keep going with me. Do I know the measure of the arc? That's what I'm trying to find. Angle AOC. Over 360. Keep with me here, Meg. Pi, what's your radius? 6 squared. All right, so we got to solve for x. We talk about this all the time, right? We got pi's on both sides. Let's get rid of them right now. 12 equals x over 360 times 36. We could do two different things here. What's your next move to get x by itself? Your next move? 5, your next move? You can multiply by 360, or you could divide by 36. Your call. You're going to have to do one or the other eventually. Okay, you're going to have to do both here. So when you get there, let me know, and let me know what the angle measurement is. When you get there, 18 when you're ready.
I don't think I got the right answer.
Why, Claire? What'd you do? Let me do it with you. What'd you do?
So I multiplied it by 360.
Okay, so you did 12 times 360.
And then I
Yep.
got 4,320.
So did I.
X over 360.
No. You just multiplied by 360, right? So that eliminates that 360 on the right side.
Oh.
So you should just have 36x equals that. See that? All right, so go ahead, finish it up, and give me the angle.
120.
Good job. Buck 20. A formula similar to that is the length of an arc. That was area of a sector. Now the length of an arc formula. Same start, but now I multiply by the circumference instead of area. All right, instead of pi r squared, it's pi d, which is circumference. This, I don't know if some of these, do any of these look familiar? Because I've used them probably on tests and or notes. So I don't think it was Dominic. I think it was Big Al, of course. Identity revealed in a couple, not next week, but the following week. We'll see who Big Al is. He thinks that angles A and B are the same. Is he correct or not? And it tells us, make sure you just read the directions carefully. Pi and 3 pi over 8, that's the arc length. That's the arc length. All right, so we need to figure out what is angle A and what is angle B. So let's go circle number 1 first. Using arc length formula, because that's what pi is. 24, here we go. What's the arc length for circle 1? pi. Is pi equal to x over 360 times, now I'm doing circumference, watch yourself, pi, Mahmood, diameter? 8. All right, I got to solve that for x now. Ooh, little tricky here, huh? They have pi's on both sides. They'll cancel out, but you better watch your mouth what you're left with on the left side. It's not 0. It's not a blank. You just basically did pi divided by pi, which is 1, right? 1. Something divided by itself is 1. So it's not a blank, it's not a 0, it's 1. Equals x over 360 times 8. Go ahead, finish that off, just like you did the last problem. Figure out what angle A is. When you're there, let me know. 1, Meg, when you have it, let me know what angle A is. Yep, 45 degrees. So now let's see if he's right. Let's do the same thing with circle 2 now, using my arc formula. 15, we're up. What's the arc length of circle 2?
13 pi over 8.
Equals x over 360 times, how about the diameter? Pi times 13. Yes, pi's will cancel out. I don't feel bad for you. You have fraction templates. Deal with it. When you're ready, 14, when you're ready, let me know circle 2's angle. We don't. Never have. You'd think I'd realize that. 18?
45
Good job. 45. So was Dominic correct? Yes, he is correct. And I know it says explain why. I think we just did here with all our work. You don't need to write a big paragraph here. All your work is good enough. What?
When they say explain them like the Regents, do you want us? How would you want us to answer?
Your work is fine enough.
Alright.
If you want to add in because both angles equal 45, that's fine. Please don't write an essay because nobody wants to read that. Serena, what's up?
Would you be able to just set them in a proportion and have like 4 over 6.5 equals pi over 13 pi over 8?
Yeah. And show that they're congruent to each actually equal. Yep. That's fine too. Anybody else? Good suggestions and questions. All right, one more sector question. Find sector BOD, area of sector BOD. Right here. Five, let's go, Greg. Here we go. Area of a sector equals measure over 360. Can you help me find the measure of angle BOD? They tell you the two arcs here are congruent. What do all three have to add up to on the bottom? 180, right?
180 minus 20 divided by 2.
There you go. What do you got? Hi, yeah, go ahead.
160 by 280.
Times pi r, Greg.
6.
Thank you. Just pay attention to the directions there, kiddos. Pay attention to the directions. In terms of pi. Please have pi in your answer. 17, have pi in your answer when you're ready.
Is it 85?
Questions on the 8? Multiply 80 over 360 times 36. You should get 8. All right, I'm going to make an executive decision here. At this point in time on this Friday, there's no reason why we need to do this. Anybody know why? We just did it. So it's pretty fresh in your mind. So I will go back when we start getting closer to the Regents and the end of school and the end of classes and start talking about these, but I think it's a waste of time doing it now because we've done this already and it's pretty fresh. All right, so I need you guys to go all the way to page where the circle stuff starts. Can you go all the way? Oh, actually, nope, sorry, partitions. Got to hit those up. Page 14. Get ready for a partition question. I'm not going to use the graph. I've never used a graph with you when I taught this to you back in the day, January or February, whenever I taught it to you. So I'm not going to use one now. I'm going to do it the same, teach it to you the same way I did back then. I'm going to break this. I'm going to break AB up into a ratio of 2 to 3. How many equal parts? 5 equal parts, right? 5 congruent parts. All right. First thing you do is you find the x coordinate. Here's how I find the x coordinate of point P. What is the distance between the x coordinates right now?
10.
From -6 to 4. You don't need the formula for this. -6 to 4. How far apart are they? Go ahead. 15. How far apart are they? 10 units. And I divide that 10 by 5. How many? I need to break it up into. So that'll be 2 units every time. What you have to figure out in this problem is, using the ratio, how many times am I going to go 2 units? Because I go 2 units, I break it up. 2 units, I break it up. 2 units, I break it up. But how many times am I going to have to go those 2 units? That all depends on that first number in your ratio. Right there. That's how many times you're going to go 2 units. So how many total units am I going to move? 4 total units I'm going to move from the beginning. All right, that first number tells you how many times you got to move. Where am I starting from on the x-axis again? On the x-axis, where did I start at? 2, where did I start, Matt? On the x-axis, where did I start? What x-coordinate did I start at? Because I'm going from A to B. -6. Thank your boy there. -6, and I'm adding 4, so I end up at -2. And now let's do it all over again, but now for the y's. How far apart are the y's? 8. How far apart are the y's, Charlotte? 9. 9?
Oh, no, wait, 5.
5. -5 to 0. There you go. 5 units away. Divide it up by 5 again. So now I'm going to go 1 unit every time on the y-axis. Again, how many times do I need to do it? The first number. The second number has nothing to do with this, and I don't even want to get into what it has to do with or what the second number is ever used for. It's always the first one. So I'm going to go 1 unit twice for a total of 2 total units. It all matters what the first number is. All right, last question here. Where did I start on the y-axis? 17, where did I start?
-5.
Yep, -5, go up 2. I should be at -3. You can leave after how many hours? 2. But we discussed from 2 to 3 hours, you're not doing anything eventful in your life. Let's be real. So you might as well check everything you can. And if you do a partition problem, you're going to check. What do I mean by check? This is where I use the graph. If I plot AB 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and B 4, 0. My partition point better be on there. That's how you can check. Your partition point better be on there, which it is. All right, finish up the 2020. We'll talk on Monday. Good work.